Hey, what's going on, folks? It's Mike here, and welcome to our C++ Quick Start series. This is a series for getting quickly started in C++. Maybe you're taking C++ as part of a course, or just need a quick refresher on just some pragmatic things that you're going to do in C++. It's meant to be a short series, and I will link my full C++ series going in detail about how to use the language in the description below. With that said, though, what we're going to be talking about today is this idea of bringing in data from the outside world into our program. So this means file manipulation or just reading some data from files. So pragmatically, this is something that you're going to have to do very often because you need data in your C++ programs that you want to work on. So with that said, let's go ahead and get into the coding here. So really briefly, I want to just go ahead and show you c++reference.com. This is a definitive guide for finding functions and these kind of things. c++.com is also pretty good, especially for beginners, to find lots of workable examples. But just to show you where we're working today on the input-output libraries here, I'll go ahead and zoom in for you just so you can see this is where we would get our definitive resource. Control F, search for file, and these are the file headers. Now we're going to be working with something called fstream, which stands for file stream. We've previously been working with something here, or similar to what's here, IO stream, input output. But specifically, we're going to be working with files. So if you want to see the functions available, you can click on here, IF stream for input explicitly, OF stream for outputting a file. Okay, so with that said, let's just go ahead and get into the code here. Let me go ahead and bring up a file here. And this is our program here. So, our entry point here, main the function, it returns an integer value, and we're just going to include IOStream by default because we might want to do some things with a file, such as reading in some data and then outputting that to a file. So I think that's a pretty good place to start here. So let's go ahead and include that fstream library here so we can work with file operations, or just to be more explicit, file IO operations. Okay. And what I'm going to do for this first example is output a file here. Okay, so what we're going to do is go ahead and part of the standard library here, again, since we're outputting files, OF stream, so output file stream, and have some sort of out file here. So this is going to create our object for working with a stream that can write out data to a particular file. Okay, so how do we do this? Well, we could use one of the constructors and specify some parameters here. I'm going to do it in smaller steps here. Just as an example, I have my out file, and then I could use something like open. And essentially when I'm opening an output file, I am creating this file here. So I'm just going to say my text file here and have some text data here. Okay, so that would be the idea. Now, because these things are streams in the sense that we have output file stream, that means we're using these wicket marks here, or the less than signs, if you will. These are really the stream operators for input and output in C++ when you're seeing those used. So if you see those referred to, that's what they mean. And it's sort of a convenient way to think about pushing data into something or drawing data out of something, if you want to think about that sort of analogy. But let's just go ahead and see how we create this file here. So if I have out file and I want to write some data to it, I could simply do it by, well, using the stream operator and say, here is some data. Okay, and I can even put in an end line here, which will effectively put a new line here. And let's just go ahead and do something else. Here is a second row, and maybe one more row here. Let's just go ahead and put in some other information here. 45, 62, 42. Okay, so just some random data. So mixing string data here in the quotations, our end lines, and then some integer data. Let's go ahead now and close our file. So when we're done with it, we do .close. Okay, so what I'm going to go ahead and do here is compile this. I didn't have it in my history. And you could use something like this. Many folks might be using Clang, or if you're on your IDEs, that's fine. And some folks might also be using different versions of C++. I typically use 17 or 20, so you're welcome to specify these flags. All of these are older features that I'm sort of showing in this quick start series, but you're welcome to do that. Okay, so we can see that this program does compile. Let's actually run it. And just to be clear, when I look at the contents of this folder, and again, for folks who aren't used to the terminal, let me go ahead and just open the folder. Well, we can see this is what popped up here. Again, main program. Again, that matches what is listed here in our contents. Okay, so I'm just going to leave this up here. Again, if you're more comfortable in a graphical user environment, sometimes it's helpful to see. I'm always using the terminal, but anyways, when we run the program here, and again, Windows users might have .exe or something, but for Linux and Mac users, just type in the program name, hit enter, and voila, like that, we see my text file here. So let's just go ahead and open this up. I'll use Vim. You can see it shows up here, and on line 1, here's some data. Here's the second row, and then 45, 62, 42. Okay. Now notice there's no space or anything between these because, well, we haven't said to explicitly put in a space here. So again, this is why streams are sort of nice to work with files. They're a little bit weird, but let's just go ahead and, you might be expecting something like this. Let's just put a character here, single quotes. Or you could use double and treat it like a string, but we really only have one character here. And let's just go ahead and, well, since we've made a change here, I've got to recompile this and rerun it. Okay. Now, when I rerun this output file stream, it's essentially just going to overwrite this file here. Okay. There's different ways that you could append to the file or so on, and we'll get to reading from a file in a moment here. So I'm actually getting a warning from my text editor that says I need to reload this file, and I've done this here. So here's some data, here's the second row, and then here is our data nicely spaced out here. Okay, so whether you're writing out text data, or meaning strings, characters, or integers, floating points, etc., streams sort of work nicely. This is pretty natural here. Now, one thing I will say is when you open a file in C++, it's also polite to close the file as soon as you're done with it. Okay, this has to do a little bit with how the operating system's working and figuring out where you're writing data to, or if multiple processes are trying to write to the same file and these sort of things. So typically we try to do this and match the pairs. Open with close when we are finished outputting to or writing to this file. Okay, so that's the quick start example on outputting a file. Let's go ahead and read from a file. Okay, so what I'm going to go ahead and do is close this window here. And for our program, let's just go ahead and get rid of this here, get rid of this, and now let's work on reading data. Now, I'm also going to modify how our program works a little bit, again, just to show you more C++ stuff, because, well, what I could do, and, this is typically what we do, is say I have a IF stream. Here's the sort of input file. And then I could do sort of the same thing here where I say infile.open and then, my text file.text or something like that. Okay. But what's going to happen if you want to read files from different locations or something, you're going to have to recompile the program. So instead, I'm actually going to provide some arguments to our main function, which we typically should provide, that'll allow me to figure out where I'm reading a file from. So main takes arguments. argc is the argument count, and argv is the variable number of arguments. Okay, so allow me to just work with this part before we get into handling files here. And basically what I'm going to say is if the argument count, or let's actually just start with something simpler just to show you what's going on. argc, so you can see the value. And then once we have the argument count, we can iterate through all of the arguments here. Okay, so we say if, or actually let's just do a for loop, I is less than argc, I plus plus, and then let's just do a cout. I'm going to just put a tab here, that's \t. I'm going to show you something new. It'll help us format our data. And then argv, this is a array here with this. And it's an array of pointers. We haven't talked about pointers in this quick start series, but we'll get to that as needed here. But let's go ahead and just recompile this to start and see if this works. So if I recompile it, works fine. And if I just run this, well, here's what we get here. I run my program here, and there's one argument by default. That's the actual program here that is run here. Okay, let's rerun this here. And typically, and again, this will be a little bit more familiar for Linux and Mac users, not as much Windows, maybe depending on your experience, but you provide an argument. Like maybe you want to say, open this file here, .txt. Okay, so you're providing the argument to main just on the command line here. And Windows is sort of doing this behind the scenes when you just double click on something. Anyway, so that's what's going on here. So now we can see that, well, our first argument is always the program name, and then any number of arguments that we have after here. So we could have, any number of arguments here, and they're just separated by spaces. Okay, so now we know how to read in arguments. That's how we'll read it in our file name. Strings are essentially character strings or abstracted around. Again, not as important that you know that for this series, but just want to highlight this. Okay, so program arguments, and one thing that we might typically do, especially since we're going to use this program to read in a file, is to say something like if argc is less than a certain amount, say 2, then we would just return early, and maybe we'd print out a message. Okay, please specify a file name, and I can put this on multiple spaces. Example, maybe we want to actually just let's be pretty detailed with this error message here. So I'll put an end line here again just to show you different uses of streams. So something like this, example /prog file name.txt. Okay, and so let's go ahead and recompile this since we've made some changes. Oops, I've got to get rid of this semicolon. Recompile, rerun, and well, this is going to be the sort of error case here. So I'll hit enter and it says argc1. Okay, maybe we don't want to print this line out, but this is pretty helpful here. Please specify a file name, and it's going to tell us how to run the program. Okay, so let's at least leave that in here. I think that's pretty useful, and then we don't really need to print out the arguments again, but that will do the trick here. Okay, so let me go ahead and make this a little bit bigger so we can see everything, and let's work on opening a file now. So we know as long as a user specifies the file name here, filename.txt, that's what they're going to be reading in. Okay, so let's go ahead and handle that by reading in a file, if input file stream. So there it is. I'm just going to call in file, or input file, maybe is a better name here, and input file open. And instead of specifying file name here .txt, again, we're just reading this in from our arguments. That's argv. And remember, the 0th argument, because we index from 0, is just the executable name. And the actual thing we want is at position 1 here. Okay. And then, as I mentioned, it's polite to also close our file. So let's just go ahead and type that so we don't forget what we're doing here. All right, so once we've opened our file, well, what can we do with it? Well, again, we might want to do some other sort of error handling things. Where do I figure out how to do these? Well, again, if I go to fstream, let's go ahead and just kind of look. There is a isOpen function here that's going to be useful, right? We learned about open and close here. IsOpen is going to tell us, well, what if the user specifies some random file that doesn't exist, they spell something wrong, and so on. So we probably want to do that. So we're going to say if our input file is open, then we'll actually do some work here, okay? And then no matter what, we want to close it here. Okay. Or I guess, at least for this example, we'll assume we always specify an operation. Maybe we want to close it here only if it's open. But I'm going to just leave this as is. But anyway, this might be some basic checking here. So anyway, when we're reading in a file, how do we get the contents of the file here? Okay, well, I think in general, we're just going to need a file. We can work with my text file here. Again, I can output the contents of that just to refresh these 3 lines. But how do I read these 3 lines of information here? Okay, well, here's the trick here. We're actually just going to use string here. Okay, so we've seen string pop up. This is a string library, and we have the string type here. Okay, so what I'm going to go ahead and do is create a string Lots of times folks will just call this a line if we're reading from it. And then we have other handy functions like get line here. So let me kind of just do this manually here. So standard, this function name is just get line. Where are we reading the line from? Well, our input file. Where are we storing the contents? Line here, okay? And let's go ahead and just, every time we do this, let's just go ahead and print out what the line is. I know for this particular file, I have 3 lines here. So let's just go ahead and see if this works here, okay? So let's compile, see if I made any mistakes. No mistakes. Okay, so we're gonna specify the file name, read it in. If we don't do this right, we'll get an error message. Open the file from our program argument and then double check, did we actually have a open file here? And then for our string here, this is where the contents are gonna be stored, and then we'll read in the data, okay? Line here is a temporary storage for each line. Okay, every time we call get line, the contents of the previous line are going to get overwritten. Okay, so anyway, let's go ahead and see what happens here. Oops, I didn't specify a name. So it was my lowercase my text file here. Hit enter, and here's what we get. Here is some data. Here is the second row, and then 45, whatever. Okay, so how can we improve this? Well, let's go ahead and put an end line here. I'm just going to copy and paste this in and get rid of these lines. Okay, so let's recompile that. Looked good to me, but I just want to show you that it is indeed running and we're reading in some data. So pretty cool here. Now, again, you might say, Mike, I didn't know. How did you know there was 3 lines here? Again, we're typically not going to know. So the sort of pattern that you're going to see is folks will put this in a while loop. And they'll say, while there's lines to get, go ahead and retrieve them and print them out. Okay, so let's just go ahead with this pattern here. Compile and run here. Okay, so it does the same exact thing here. So this is a change. We're saying while there are lines to essentially retrieve. So the get line function is always checking the input file and saying retrieve a line. Was anything retrieved? If there was, then continue, and then we'll execute this code here. Okay, so I do want to do a little bit with file parsing stuff, because sometimes this data is, something that we have to work with, or maybe we just want to grab one of these integers at a time. But let me take a pause just to refresh what we have learned so far in this lesson here. Okay, so let's go ahead and just recap, and then we'll talk a little bit about file parsing with something called stringstream. Okay, so we started off with fstream. So I'll just write it out like this: include fstream. And then we know that we have things like ifstream for input and ofstream for output. Okay, the ability to read in data and write out data. Again, typical pattern that you might be doing in your programs: read in a bunch of data and then output, the manipulated data in some way. We've also learned about program arguments. That was argc, which is the argument count. Okay, how many arguments were specified after the binary? Right, we always have at least one. That was the binary name. And then we have argv, which is the actual arguments stored in a character array. Okay, that was this thing. And we got to talk about this thing a little bit more, or in my other series here. Some folks might have seen this if you're coming from a C background. It's just char star star, essentially the same thing. But we're saying we have, okay, brackets, which means an array. And this is essentially what a string is: a pointer to a bunch of characters that are lined up. Okay, might not make exact sense right now, but that is the type here. Okay, now what we need to talk about is parsing a string. Okay, so let's slow down for a moment here. Go to CPP reference and just go to let's just go to the home page here. I'm going to do Control F with string, and we see our string things here. String library, standard string is what we've been working at. So let's take a look at that. And we have all sorts of things that we can do, right? We could see at, which I believe we've looked at previously. We could use the operator to sort of get things. We even have handy stuff like substring, which just returns part of the string. So let's just start with some of these here, because sometimes what you want to do here, just thinking about the types of data that you want to format. So let's just say if line, the 0th character equals some character here. Like if you're reading in a Python file, maybe we would just want to ignore it. Okay. So we do something like this. So if our data starts with a pound sign, just ignore that line. Okay. And let's actually look at our text file. I'm going to modify my text file here. My text file. And let's just go ahead and put in some pound signs here. You know, this is a comment. Oops. And, you know, this could be some other comment. More data below here. Okay, so we just have, information like this. So basically, this could be a common thing that you have in file formats, or if you're parsing scripts or actual code that you might want to just ignore some stuff. So don't underestimate the ability to do this here. Okay, and we could write this many different ways. I'm doing this simple. We could just say, if not this, and avoid having a block here. Again, we don't have to be efficient while we're learning. But let's go ahead and compile this. I'm going to run it. We should see our error message. Okay, so I got to specify our file name, my text file. And now we just have the data, okay? Because again, if I output my text file, it ignores all of these lines that the first character starts with a pound symbol. Okay, now there might be other tricks or things that you can do here, because you might want to handle the case where if there's a bunch of spaces and so on, but I'll leave that sort of as an exercise for you to do here. So again, you can look at some of these functions here and think about, well, maybe I want to replace white space, or, there's even other nice functions in C++23 to see if something contains a certain character, or maybe if it starts with something. Again, all sorts of little routines or algorithms that you could write. Okay, maybe you want to write a function that just detects white space and say, is the first non-white space character a pound symbol? Okay. Anyways, enough on that. Now, what about this here that's kind of interesting? 45, 62, 42. Well, right now I'm reading that in as a string. Okay, but very clearly in our first example, we were actually, when we were writing out this data, if you recall, I was writing an integer and then a space and then an integer and then a space. So clearly, at least maybe if I have some insider knowledge here, these are 3 separate datas, but I'm retrieving them as a string. So the question is, how do I take this line and break it into separate components? Okay, so what I'm going to do to work with this, again, I'll go back to CPP reference just to give you sort of a some of the keywords. So let's go back to C++. And let's see if it shows up here. So if I do stream, okay, stream-based IO. Let's take a look at that. And oh, this is kind of interesting. And I'm gonna save you some time and give you sort of the, if I kind of scroll through here, we were looking at file IO implementations. So this was reading in data as a stream. But you'll notice down here, there's actually ways to work with string IO here. Treating a string as a stream. So we can use those, again, less than or greater than signs, again, the stream operators. And the one that we really want to be working with is stream here. So I'm going to go ahead and click on this here. It's defined in ststream here. And let me see if I can actually find the type, or I'll just show you here. But anyways, there's different things that we can do here. Let me just go to stringstream here. And see if there's any examples. Well, I'll just show you the example. All right, but this is what we're going to be using, the stringstream, which again allows us to just take a string and treat it as something where we can use those handy operators, just like we've been doing with cout. Look, where we're sort of writing out or telling what data to output here. Okay, so again, let's see. So if we have our comment, do nothing here, do nothing. But otherwise, let's handle this here. So I'm going to need to include a new header file here, fstream. So string stream. That's the type here. String stream. And the classic sort of example of how to use this, which is what I'm going to do here, is just to create a string stream. I'll just call it stream. And part of its constructor is, well, what's the string that I'm going to construct this with? And that's just going to be a line here, okay? And then what I'm going to go ahead and do is, well, the same sort of trick here. And I'm going to basically say, what are the individual components here? So again, I can sort of, just in the same way that when we're writing out the file here. So this, let me give you some comments here. String, so construct a string stream from our line. And then again, we want to break down each of these individual components. Break out each individual component based off of spaces or some delimiter. And there's many ways that you can do this. A string stream, I'm just going to use this as a simple example that'll work with spaces here. And then we could basically just say, while in our stream, we just output something like a word or a chunk of data. Okay, now what is our chunk of data here? Well, what if we want a string like this? And let's just go ahead and write out our chunk of data here. Okay, so let's go ahead and compile this. Let's see if it works. Does it work? Okay, well, it compiled. Let's go ahead and run this with our input file here. And, okay, what did I do here? Well, I'm writing out line 3 times, so I don't want to do that. Let's actually write out the chunk here. A little bit of debugging here. So I suppose that we need to recompile, rerun with our input file. And now we can see that we have 45, 62, and 42, which were those 3 numbers that we saw before. So again, just to recap this code here, we're opening a file from our arguments, checking, okay, was this actually a file that existed or was there some sort of problem? And then we read in each line from that file here, okay, and then we keep doing that in a loop. And then we start sort of parsing or interpreting that file, because the file might have different things, you know, a pound symbol might mean something like, hey, there's a comment. So we just ignore those things. Then otherwise, we might have some other logic where we handle things. And string stream is a handy way to say, hey, here's a line that might contain a bunch of data that, again, might be formatted or sort of space separated, or maybe there's a comma separating things. Again, there's different parameters you can use with string stream depending on your data. And again, just sort of using the same trick like we were using up here and just saying, okay, now just give me a tiny chunk of that data here, okay? And then read it out. Again, the arrows are going, you know, look at the direction. I'm taking this stream and saying, hey, write out the data to this chunk here, okay? That's the idea. Now, there's still some problems here. And I just want to quickly do a search. Maybe the astute student has looked at this and said, well, Mike, you're still storing that integer data as a string. You are correct. And let me see if I remember the functions offhand. I believe this is the one we want. These sort of conversion functions here, stoi, stol, stoll. Well, what do these do here? Let's see if I can find a... well, I can find a couple of examples here down in our documentation. So getting a little bit used to our documentation. Basically, string to integer. That's how we interpret this. S2, and then the type I here. STOL is a string to long, so maybe you have a longer type here. And then there's other functions here as shown, like converting strings to floating point data and so on. So here's just some of the things. So let's go ahead and just first check the header file that this is included in. And it looks like this is part of the string library, so I don't think we need to include anything. And when I'm actually writing this out, since I don't know the actual data, I'm just going to handle it here, string to I, meaning that there could be 45 and then 62.2 or something. So you might want to use string to f or whatever, be kind of conservative. But let's just go ahead and do that. Recompile, rerun. We won't see a difference in the output, but in your code, if you're storing this, so for example, a common thing you might do is say int I equals or int data, or maybe you have a array, so data at some index here, or even better if that's a vector, you can store this chunk of data here in the right format. So last thing here, data equals string to I, string to integer, whatever that chunk of data is, and then that's what we're actually going to output here. Okay. So, is this production grade code? No, but, now you know how to sort of break down a file and structure things, okay? Now, a good exercise for you to do after watching this video here, right, if I scroll through the code, would perhaps be to write a little class here that takes in all that we've done here and puts in the constructor, the arguments for opening whatever data type you're trying to parse. Maybe it is text files or whatever this data is. And the destructor calls close, so you don't have to remember to do that. And then you can have little functions like parse or read entire file and maybe store that data into some sort of vector, for instance, or maybe an array. I would say just prefer vector to make things easy. And then, hopefully this will be useful. So folks, with that said, I'm going to go ahead and close down this lesson. But before I close it down, I'm actually going to bring you back here. Just want to take you to the whiteboard to recap that we learned how to parse a string here with string stream, that library. And I'll just go ahead and put another bullet here for string stream, again, which is treating a string here, str, I'll just abbreviate it, or what we use, say a line, however you want to remember that. Again, I'm just going to put str so you remember it takes in a string and constructs a string, which we can use those input and output stream operators for. Okay, now I'll go ahead and shut us down so you can see the review here. I hope this was useful. I hope this sort of gets you confident and excited about working with data in C++, especially with modern C++. It's quite fun to work with some of these stream operators and do this parsing, because we've gotten lots of neat functions that we can use and make our life easier, especially if you're coming from a background in Python or other languages that have very extensive libraries. All right, folks, so with that said, make sure you like this video if it was helpful, comment below if there's something I didn't explain well, subscribe if you don't want to miss these other videos, or do remember to check out my longer C++ series if you want to go more in depth. And with that said, we'll go ahead and see you in the next one.